Today we are going to review 2 watt 20 dB RF attenuator. We will use it with Meshtastic sometime in future. Here I have RF attenuator with the red and black caps, SMA cable for VNA, 2 patch cables with male SMA connectors on both ends, and the nano VNA. Let's open up the attenuator. This label shows the type of attenuator and its value. It is usable up to 6 GHz. On one side it has SMA female connector and on the other side it has SMA male connector. This RF attenuator is not directional, so you can use it in any direction. Connecting patch cord with the attenuator and other end of the attenuator to port S11 of the VNA. For the test we are going to perform today, we need to calibrate port S21 of the VNA. Here is a video explaining it. Other port of the patch cord is attached to port S21 of the VNA. Before going ahead with the actual measurement, we need to make sure that we have calibrated it correctly, and we need to check that the cable is showing 0 dB on channel 1, which is port S21. We are doing this test for 868 MHz. Frequency was wrongly set at 907 and here it was showing minus 0.11 dB. So I just changed the frequency to 868 and now it is showing 0.0 dB. This setup is ready to test any RF attenuator. After attaching the attenuator with the help of patch cord, we can see that log mag is showing minus 19.85 dB on channel 1. Channel 1 is S21. This is the intended channel. This figure is very close to the actual value of the attenuator, which is minus 20 dB. Value is written as 20 dB, but attenuator is automatically minus. It always reduces power. So that's where minus came from. This attenuator is almost okay. If you want to know more about attenuator, please watch this video. In this test setup, VNA transmits 0 dBm power from its port S11. This power enters this attenuator and it reduces it by 20 dB. So on this end of the cable it becomes minus 20 dBm. What is dB? Please watch this video. And this minus 20 dBm flows through the patch cord and enters port S21, and it is shown on the VNA screen as minus 19.85 dBm, which is very close to the expected value. See you again in another video.